Hi guys, thanks for coming back to my YouTube channel. This video is section 2.5 for my calc class dealing with examples of implicit differentiation. So let's dive right in here. We got implicit versus explicit equations. Implicit equations have x's and y's in them, and they're not solved for y in terms of x. So to find a derivative of an implicit equation, we actually break it down into 4 steps here. Step 1, we're going to take the derivative of the entire equation like normal. We got power rule, chain rule, quotient rule, whatever we got to do there. But when we take the derivative of y, we got to tack on a dy dx. Then we're going to collect all the dy dx's on one side. It's usually the left side. Factor out a dy dx, and then we're going to solve for dy dx by dividing. So when it comes to it, there's only really one step of calculus here where we take the derivative, and the rest of it is a lot of algebra after that. So let's get started here. Let's take a look at the first example where we're going to be taking the derivative of a circle. If you remember from pre-calc, got x squared plus y squared equals 16. That's a circle at the center with a radius of 4. If we go ahead and start off here, the derivative of x squared is 2x. And so I'll have 2x, and then the derivative of y squared is 2y. But right here, again, because we took the derivative of y, we're going to multiply that by a dy dx. Some books will use y prime. I like using dy dx because you can see it a lot better. That y prime sometimes blends in with the y for the derivative over here with the 2y. But I like tacking on a dy dx. And don't forget, you're taking the derivative of the whole thing, so the derivative of 16 is 0. Alright, so now we got to collect all the dy dx's on one side. So we only have one this time, so we'll leave this to stay put. So we'll have 2y dy dx equaling negative 2x. Don't forget your basic algebra rules. When you move something from one side to the other, you flip the sign over. And so usually we factor out a dy dx if we have more than one term, but we don't have more than one term, so we just have the dy dx here. So all I'm going to do now is divide both sides by 2y. So dy dx is going to equal a negative 2x over a 2y, and just to simplify there, the 2's are going to cancel. So our derivative will wind up being negative x over y. Alright, so that was a pretty basic one. Let's dive into a little bit, one that has a little bit more into it. I got the next one here that has a product rule in it, and these always show up with implicit differentiation. And the one thing you want to make sure of right here is that you recognize where the product's at. So right here, this 3xy right here, that is your product rule, because we got a couple things that are being multiplied. So let's dive right into this one. So derivative of 2x is 2. Alright, I'm going to treat 3x as the first term and y as the second term. So we'll talk our way through the product rule here. So we know that that's first times the derivative of the second one. The derivative of y is just 1. And then we have to tack on a dy dx plus the second times the derivative of the first. The derivative of 3x is 3. Alright, and then we got the derivative of 2y, which is just going to be 2 dy dx, and then the derivative of 15 is 0. Alright, so now the rules say get all the dy dx's on one side. So we're going to leave this put and leave this put on one side, move everything else over. So I'm going to have a 3x dy dx plus a 2 dy dx equaling, we're going to have a negative 2 minus 3y. Alright, so now I have two terms, so I'm going to factor out a dy dx because they both have that. I got 3x plus 2 equals a negative 2 minus 3y, and then my last step is just divide. So my derivative, dy dx, is equal to negative 2 minus 3y all over 3x plus 2. Okay, so again, one step of calculus right here at the beginning, and then the rest of it's algebra from there. So let's keep going here. Some different types of examples. Here's one with the chain rule. A lot of algebra when we do with this one. So remember, the chain rule is the derivative of the whole thing times the derivative of what's inside. So if we do the power rule for the whole thing here, we're going to have 8x squared plus y squared to the first times the derivative of the inside. So here we go. We're going to have 2x plus 2y dy dx. Okay, so there's the derivative of the whole thing times the derivative of the inside equals 30. Alright, now I'm going to distribute the 8 because we've got a lot of algebra to go here. So we're going to have 8x squared 8y squared times 2x plus 2y dy dx equaling 30. Now to clean this up, we have a binomial and a binomial. We're going to have to FOIL this out. Alright, so if I FOIL this out, I got 8x squared times 2x. That's going to be 16x cubed. Outer is going to be a 16x squared y dy dx. Inner is going to be a 16x y squared. And finally, a last is going to be a 16y cubed dy dx, and then finally equaling 30. Alright, dy dx is on one side, so we're going to keep this one and keep this one and move everything else over. So I'm going to have a 16x squared y dy dx plus a 16y cubed dy dx equaling 30 minus a 16x cubed minus a 16xy squared. I'm going to factor out a dy dx. So I'll take out the dy dx and I'll have 16x squared y plus 16y cubed in parentheses. 30 minus 16x cubed minus 16xy squared. And then finally, to divide, let me scroll this down just a little bit. So if I just finally divide by this, I'll wind up with my derivative equaling 30 minus 16x cubed minus 16xy squared all over 16x squared y plus 16y cubed. So again, derivative at the top, one step with the chain rule, taking the derivative of the whole thing, and then all this algebra here after that. So make sure you take your time with that. Alright, let's move on. Alright, so let's see here. We did one with the chain rule. We got one in here with a trig function. Same thing here, but if you notice, hopefully you did, right away before we even started here, we've got a product rule right here. So we're going to practice that one again. Alright, so the derivative of 3x squared is going to be 6x. What's the derivative of sine? That's cosine. So we're going to have 5 cosine, well, put the y there, 5 cosine y and because of the y, we're going to tack on a dy dx. Derivative of 4 is 0. Okay, and now here's our product rule. So first, negative 5x times the derivative of the second. That's 1 dy dx plus the second y times the derivative of the first, negative 5. Okay, so all the dy dx is on one side, everything else on the other. So I got to move this over and the 6x over. So I'm going to have 5 cosine y dy dx plus 5x dy dx equals negative 6x minus 5y. Factor out a dy dx. Got 5 cosine y plus 5x equals negative 6x minus 5y. Dy dx is equal to negative 6x minus 5y all over 5 cosine y plus 5x. So there's your derivative there that has a trig function and a product rule in it. Alright, what else we got here? So the last but certainly not least here, we are going to find the equation of a tangent line. So again, remember what a derivative is. That's the equation that represents the slope. So now I actually want to find the slope by plugging in x and y to our derivative equation, and then we'll use point slope form and find the equation of that tangent line. So wow, look at this. Again, shows up. We know it's going to happen. We got a product rule. They show up a ton. Alright, so let's try this again. So it's first times the derivative of the second, which is 2y dy dx, plus the second, y squared, times the derivative of the first, which is 2x. So there's first times derivative of the second, plus second times derivative of the first. So there's your product rule. Derivative of negative 2x is going to be minus 2. Derivative of 3, 0. Alright, so clean this up here. I'm going to have 2x squared y dy dx equals, now I'm going to move this on the other side here, so I'm going to have minus 2x y squared plus 2, and therefore dy dx is going to equal a negative 2x y squared plus 2 all over 2x squared y. Alright, so now to find the slope, I got to use the point negative 1, 1. Alright, so plugging that in, I'm going to have a negative 2, negative 1, 1 squared plus 2, 2, negative 1 squared times 1. So what are we going to have here? We're going to have 2 plus 2, that'll give me 4, and 2 on the bottom, so my slope is going to be 2. So now with a slope of 2 and a point of 1 and a negative 1, 1, I'll go up here. I'll use point slope form. So y minus y1 equals mx minus x1. So I'm going to have y minus 1, 2, x minus a negative 1 will turn into plus 1. Y minus 1, 2x plus 2, y is equal to 2x plus 3. So there is our equation of the tangent line going through the point negative 1, 1, where we had to find our slope and our derivative implicitly because we had x's and y's in our equation. So hopefully these examples helped you in section 2.5, and keep visiting my page, guys. I appreciate it.